So hello everyone, welcome to my YouTube channel. So we will try to solve one DSA problem. So this problem is a scenario based problem. Let's quickly read the problem statement and find what it is saying. So the problem statement is all mail in your mailbox are sorted chronologically. Can you find the first mail that you have received in a particular year? So you have given an array of all the number of mails that you have received. You have to find the first mail that you have received. You have to give the index. So let's say that if the k value is 2020, then the first occurrence of that mail is the index 3. So the value will be 3. You have to return 3. Suppose let's say you have to return 2024, then the first occurrence of that element, so 2024 came in at 13 index as well as 14 index, so you have to return the first occurrence, so the final value will be the 13, right? So now looking at the problem statement, what can be the brute force approach that directly comes to your mind? So the brute force approach is, as we have to find the element, as we have to search the element, so the searching is, one of the searching is linear search, right? We can traverse the array element and we have to find, if we find the first occurrence of that particular year, then we will get the element, right? So we will just simply return the index of that element, right? Now the time complexity of linear search is, in the worst case we have to visit at the last element, right? So the time complexity is order of n. Now can we further improve this approach, right? So from the problem statement it is clear that the array is sorted, right? So if the array is sorted, so one approach, one searching that we can use is binary searching, right? One binary searching is, so can we apply binary searching here, right? So let's apply the binary search and then we find the index of that first occurrence, index of k, which is first occurrence, which is the first time it is coming, right? So let's take one example and let's consider what is the worst case for this approach. Or let's take from an example, let's say the array element, all the element is having same value, 10 10 10 10, right? So let's do some indexing, 0, right? So here if we apply binary search, this is the low pointer, this is the high pointer, right? So 0 plus 7 by 2, which is nothing but 3, right? So middle element is 3, right? So then after getting the middle element, then we can go to left, because that is the value we want, that is the element we want to search. We wanted to search 10, right? So we got in the middle element 10, right? But this might not be the first occurrence. To get the first occurrence, there might be, because the array is sorted, the element will also be exactly same, so we have to go to the left side, right? Now the worst possibility that can happen, the worst case that might happen, the element will be the first element, right? So you have to go n by 2 times left side, right? So if the time in this scenario the time complexity will be 1 plus n by 2. 1, we applied binary search to get the middle element, and n by 2 times we will do traversal, because the worst case possibility is the element is the first element that you want to search. So the time complexity is order of n by 2, right? This is the optimized approach, but it is still, time complexity is order of n, right? Order of n by 2 is nothing but, it is approximately order of n, right? Can we apply binary search in a more optimized approach? So let's get the optimized binary search. Again, let's write the array element. What was the array element? Let me quickly write that, which was the year, right? The element which was in the year. So this was the initial array element that we have given, right? Let me do the indexing of the array element as well. And let's apply the binary search approach, right? So optimize binary search. Let me apply the binary search. So there are two pointers, low pointer, high pointer. Then we will find the middle element, and then we will based on the condition we will apply some. Based on the condition, what we'll do, we will take some action, right? So let me draw the column. Okay, right. So let's initialize low, and it will be the first element and high will be the last element, right? So low value index is 0, high value index is 14, right? So to find the middle element, we know how to find the middle element. We know the formula finding the middle element is low plus high by 2, which is 7, right? Now the 7th will be our middle element, right? Now because we wanted to search k is equal to 2020, that is the element that we wanted to search, right, which is same as the middle element. So in this case, array of mid, the element which is present in the middle element is exactly equal to k. Now there might be possibility that it can be the first occurrence, right? There can be the possibility that the element that we are searching is in the first occurrence only, but still we have to check, right? We have to check whether it is exactly the first occurrence or not. It might be that it may be the first occurrence. So because the array is sorted, so we have to go to the left side to validate whether this is the first occurrence of that element or not. So what we'll do, we will store the middle element in a particular variable. We will define one variable. Let's say the variable is answer. We will store the middle element of that variable, and what we will do, we will go to the left side. So to go to the left side, what we'll do, we have to update high pointer variable by reducing the search space. So this is how you can reduce the search space. High is equal to mid minus 1. Now this is the updated high variable. Now this will be your search space. So you have to search space here. So you have to apply binary search in this search space. Okay, let me quickly update this. Now initial low value was 0, right, and high value was the updated value. Here the mid value was 7 minus 1 6. So the updated high value is 0 6. Now we will find the middle element, 0 plus 6 by 2, which is nothing but 3. Now we will go to the array. What is the here? This is the final mid element, right? This array of mid is equal to the k, right? So we will again, this condition is satisfied that array of mid is equal to k. So in that case, what we'll do, we will go to the left side. We will update our answer variable to the initial variable, which is mid. Now the mid value is 3, and we will also update high pointer variable. High is equal to mid minus 1. So the mid value was 3 minus 1 was 2, right? So low was 0, high is the updated high value 2. Now we will search, we will calculate middle element. To calculate the middle element, formula was low plus high by 2, which is nothing but 1. Now we will check array of mid. What is the array of 1? So the array of 1 is 2019. Now this mid, now array of mid is less than the desired search that we wanted to do, right? So what will be the condition here? The array of mid is less than the k value. So in that case, what we will do, now this is the updated condition. So in that case, we have to search in the left side. So to search the left side, what we have to do, we have to update our low pointer variable. To update the low pointer variable, we have to use this formula. Low is equal to mid plus 1. Now mid value is 1, 1 plus 1 is 2, right? So now in the next iteration, the low is updated to 2, high is again 2. Let me draw this. Right, low is 2, high is 2, and middle formula calculation is again 2, right? Now what is array of 2? Array of 2 is 2019, right? but this array of mid 2019 is again less than the desired search that we have to do. We have to search the first occurrence, which is 2020, right? So again the same condition applied here, that array of mid is less than k. So in that case what we will do, we will again update, we will have to go to the right side. So we'll update our mid pointer, a low pointer, right? So here the value of mid is 2, 2 plus 1 is 3. So the updated value of low is 3, high is 2. Now see, in this case what we have to do, we have to, loop should be ended, right? Because low is greater than the high. So in that case we have to end our iteration, right? So what are the, let me quickly summarize what we have did, what are the action that we have taken. So the first action is, if array of mid is equal to the k, which is the element that you wanted to search, right? So in that case what we'll do, we will store that mid in a variable. Let's say the variable is answer variable, and we will go on the left side, right? So if we go on the left side, then we have to update our high pointer. So high will be updated to mid minus 1. We will reduce the search space by half. The second action is, if array of mid is less than k, then what we will do, we will go on the right side. So to go on the right side, we have to update left pointer. So left pointer is mid plus 1. We will again reduce the search space by half. So this is the action we have to take, right? Let me write the algorithm. Let me quickly write the pseudocode of the approach. So we have to do mail search. So let me write mail search. Here there is an array that where you want to search, and we will, the element is stored in the value of k, right? First step is to initialize low and high pointer. So low is initialized to 0 and high is initialized to n minus 1, because the array element is present in the n. The number of element present in the array is n, so that's why high is n minus 1. Okay, now we will have to return something. So we will store an answer variable. We will initialize with minus 1, then we can update our middle pointer, right? Now the condition is, while low is less than high, or it can be equal to high. In that case also you can stop. While low is less than equal to high, first we will have to update our middle pointer. So formula to calculate the middle element is the way we have calculated. There is another formula, low minus high minus low by 2. So this is the condition, this is the formula for calculating middle element, right? To avoid overloop or to avoid some overflow condition, basically to avoid overflow condition. This is how you can find middle element, right? Now we'll write the condition that we have written in our index. So if array of mid is equal to the k element that you wanted to search, then in that case we will update our answer to middle element. We will store the index of the middle element, and we will go high is equal to mid minus 1. That means we are going on the left side, right? Else, if array of mid is less than k, then in that case we will simply update our low is equal to mid plus 1. We will go on the right side, right? And then the loop is ended, and finally what we'll do, we will return answer. We will return the middle element which is present inside the index element, right? So this is how you can solve this problem, right? This mail search problem. Now quickly let's find the time complexity. So as you can see, in each time we are reducing the search space to half. So the time complexity for this approach is, first the search space was n, then it reduced to n by 2, then it reduced to n by 2 square, then it reduced to n by 2 cube, and so on. Finally one element will be present, right? So you can see each time the search space is reducing to half, so the time complexity is order of log n, and we also know that the time complexity of binary search is also log n, right? We are using the binary search approach only, right? So this is how you can, and the space complexity of to solve this problem is we are not using any search space, we are using constant search space, we are not using any added updated variable or array. So the space complexity is also order of n, right? So this is how you can solve this scenario based problem, right? Okay, so thank you for listening.